Okay, we will move forward. Our next category is Product and Equipment Innovation of the Year. And we'll have Jenny Yan, ITA past president, to moderate this session. Thank you, Jenny, please.
Thank you, Andres. And good afternoon, ladies and gentlemen. I think welcome back to the ITA Awards Conference 2024. And we are now going to have roundtable number 5 on Product and Equipment Innovation of the Year. In my view, innovation is essential to the tunneling industry's success, as it drives improvements in safety, efficiency, and sustainability. Moreover, by innovations, our industry can overcome even more complicated challenges. So we have 4 outstanding finalists in this category. I would like to welcome all the finalists of these 4 outstanding projects on the stage. Professor Huang Honghui, and Paul, and Mr. Zhang, and Dr. Sehara, and Mr. Han. Welcome on stage. So everybody on seats. Okay, so we have 4 outstanding projects, and now I think we would like to go through one by one. So, but before we go to that, so would you mind to introduce yourself, but just short? So, maybe.
Well, thanks, Chairman, ladies and gentlemen. I'm the Hongwei Huang, the full professor from Tongji University in China. And I'm also very happy and to enter into the final, that's the round. Okay, that my colleague is Mr. Paul. Okay.
Yes, good afternoon, everybody. I'm also very honoured to be here. My name is Paul MacArthur, and I represent the company in the UK.
Thank you. Your turn.
Good afternoon, everyone. Good afternoon, Madam Yan. I'm Zhang Penghui from China Railway Tunnel Group. Today I will bring one new equipment, the 0 to 90 degree belt conveyor system. This is a very interesting solution. Hopefully, will useful for your future project. Thank you very much.
Sorry, what's your role in this project?
Actually, I'm the we are the I'm from the Port Railway. Water resource projects. We use this equipment in our project.
Okay, thank you. And
thank you, dear Mrs. Moderator. My name is Miguel Segarra. I am the head of the R&D and Innovation Department at Dragados. But I'm here today representing the team of researchers formed by 5 different people coming from 5 different departments across 2 continents that have been able to implement our Shogun device, which we are using right now in all our projects with shotcrete.
Okay. Good afternoon, everyone. My name is Han Bo. I'm from CIEG Technical Center. I'm an engineer who designed TBMs, and I'm very glad to present our latest TBM. And this is a TBM tells people how we brought green power to China. Thank you.
Hi, my name is Oliver Hartke. I'm working for CREC here in Europe, and Han Bo, my colleague from China, invited me to join his presentation. Thanks.
Okay, thank you very much for your introduction. Because the time is very limited, so we need to go through all these outstanding projects, one by one. So let's. Okay, the first one. So I hope. Oh, great!
In this presentation, All our key elements of the system have been jointly developed by Tongji University and Shanghai IDPR, led by Professor Hongwei Huang. Wyson Innovation, led by Mr. Paul MacArthur and the key members. Over the past 18 years, our team has dedicated to pioneering advanced safety risk sensing through collaborative efforts among industry, academia, and research institutions. In the 21st century, the world has witnessed an unprecedented boom in large-scale infrastructure development. The increasingly extreme disasters brought by global climate change and individual human factors coupled with highly uncertain geological environment poses significant challenges to engineering safety risk sensing and management in tunnel and underground engineering. According to Munich Re Group's tunnel safety accident data, the tunnel collapse rate can be reduced from 54 to 4% by using an efficient real-time monitoring system. Over the past 15 years, the development of wireless sensors network (WSN) systems for infrastructure monitoring has been increasing rapidly. It is well known for its near real-time data transmission, battery-powered and strongly adaptive features. It has been heavily applied in daily monitoring projects globally. The essential components in wireless monitoring are gateways and nodes. The leading companies such as Wyson, Sensive, World Sensing have proven the conclusive advantages on wireless over wired monitoring. However, the wireless monitoring industry is reaching a limit in tunnel and underground engineering when the three critical monitoring challenges are unveiled. They are unstable data transmissions, non-cooperated measurements, slow responded early warnings. Our Advanced Hybrid Wireless Sensor Network, short for HWSN system, for the first time, has systematically and structurally defined the next generation of WSN monitoring for safety risk sensing in tunnel and underground engineering, while properly addressing the three challenges above. Static mesh is specially designed for long-term structural health and safety monitoring. When the deformation trends occur gradually over extended period of time, that is, the deformation on a newly constructed tunnel requires to be tracked and analyzed due to an overlaying river over seasons. This helps users to build full portfolio of feedback data for structural behavior understanding and future improvements to underground design and innovations. More specifically, the multi-hop topology enables any node acting as a relay. So, for a node radio signal not directly reachable to a gateway, the relay is self-organized to assist on data forwarding. This is important for confined environments, where radio signal varies significantly over small distance due to multi-path effect. The ultra-low power design enables gateways and nodes to run for years with internal batteries and small in sizes. The multi-sensor interface feature enables our interface with node to power and sample all major sensor types globally. And more. In August 2015, we installed the world's longest 20.4-kilometer metro tunnel WSN monitoring system, containing 520 tilt nodes and 20 gateways in Shanghai. The system was upgraded to HWSN mesh system in 2021 and has successfully issued warnings in 55 engineering disturbance conditions. That is, excavation and overloading above the metro tunnel. We have witnessed 9 years outstanding performance from our system. Built upon our static mesh, trigger mesh is ideal for long-term event and emergency trigger monitoring, where deformation changes can be rapid over a relatively short period of time. For example, falling rocks near a rail tunnel entrance due to earthquake or other disturbing factors. Event detection and warnings are fast and autonomous in response by the system on site when power and cellular network are out of service. Gateways and nodes report data as low sampling interval for long-term trend capture, while listening to a mesh trigger ping and ready for triggered actions. Certain nodes as guardian nodes can provide as fast as 4 milliseconds response time to events. The guardian then immediately issues a mesh trigger ping and activates all nodes and gateways for a full-speed sampling and warning. We supplied slope embankment monitoring equipment for compromised railway cutting. The site features a 200-meter section of cutting at a 60 degrees angle, which is threatened by badger activity. The deployment of the Wyzen Trigger Mesh Event Detection System, coupled with the Wyzen Visual Camera Unit, has significantly enhanced the safety and monitoring capabilities at the compromised cutting site. Furthermore, dynamic mesh is ideal for long-term high-volume data-related monitoring, where physical changes require high data rate or volume over a short period of time. For example, vibration response analysis due to a moving train inside a tunnel. Highly accurate time synchronization algorithm is designed for efficient data communications. 2 decades being the leading team in WSN industry, we have achieved gold medal in the 49th Geneva International Exhibition of Inventions, 24 invention patents, 40 high-standard industrial products, 15 international known certifications, the unique global distribution network via Leica Geosystems. Since March 2021, our HWSN has served 1,200 commercial projects in 20 countries and avoiding 300 major accidents by timely warnings in the real world, and more. We are honored to contribute to shaping a safer, smarter, more resilient future for the global development in tunnels and underground engineering.
Wyzen has been leading the technologies in the WSN industry at all different aspects. We are looking forward to finding more advanced WSN capability with Wyzen in the near future.
Very impressive, I have to say. In this category, we have 4 outstanding finalists, but they are all different. So this one is about the safety monitoring system, innovative one. And the others are all different. I think the next one will be about innovative continuous conveying belt equipment from China Railway Tunnel Group. So let's watch.
The presentation will include 4 parts. This is the first part, project overview. Developing deep underground space to create a green and low carbon future city has become the trend in urban development. The construction waste generated by various underground space is mainly transported out of the tunnel through vertical shaft. Nowadays, the underground space goes deeper. The ground conditions become more complex, which leads to speed up construction technology innovation and efficient marking solution for deep underground space. Marking through vertical shaft mainly relies on crane as well as mark tank and gravel bucket. It has many disadvantages, such as low efficiency, high safety risk, large distribution to other process. It needs a safe, high efficient, green and environmentally friendly equipment, which is with high automation, easy to operate, weld applicability, good process coordination, and can adapt to 0 to 90 converting conditions. This equipment was used on the Pearl River Delta Water Resource Allocation Project, A6 section. The A6 section of civil construction is a double-track water tunnel with a diameter of 6 meters, with a total length of 7.79 kilometers, including 3 working shafts and 3 TBM sections. 2 slurry TBM and 4 EPD TBM were used for construction. Material and mark are transported vertically through the vertical shaft with a depth of 57 to 16 meters. This machine was developed by China Railway Tunnel Group and co-operated by China Railway Tunnel Consulting, Xi'an Jiaotong University, Henan Zhongye Heavy Industry Machinery were used by Beijing Subway, Guangdong GHD Pearl River Delta Water Supply. The second part is equipment innovation, the equipment working principle. The marking removal equipment, including horizontal transportation system, shaft bottom loading system, vertical transportation system. The soil generated by TBM will be transported to bottom of the shaft through the horizontal transportation system, then transferred to the vertical transportation system by loading system, and finally transported to the surface from the vertical transportation system. The equipment functions, the horizontal transportation distance can be more than 1.5 meters. The vertical transportation height can be 5 to 100 meters with 0 to 90 degree inclination. The mark to be transported can be soil, silt, clay. This equipment integrates various innovative technologies. The continuous vertical marking system realizes continuous transportation TBM mark and synchronous operation between marking and segment transportation. Reduce the shutdown time of the TBM. The system can be used in one shaft with different construction conditions. We have developed a continuous marking technology during TBM partially launch. A transverse belt conveyor was arranged below the discharge port of TBM belt conveyor to transfer the mark to the horizontal transportation system. Originally, this machine cannot be applied in sandy gravel and silty clay. Therefore, specific soil conditioning technology was developed to improve the transportation performance of sandy gravel and silty clay. This picture is showing the soil conditioning technology for the sandy gravel, and this picture is showing the soil conditioning technology for the silty clay. We have developed a centralized control technology based on TBM mark volume. Multiple functions such as online detection of mark volume, conveyor linkage control, conveyor belt overload, deviation warning were integrated to improve the safety of the marking system, which is conducive to achieving information-based digital and integrated construction management. A dynamic monitoring, safety, and self-control security technology was developed. Various protective measures can achieve dynamic monitoring for the operation state of the conveying system. The marking of the system can be shut down automatically in case of the abnormal condition. A faster and efficient unloading technology was developed. The active taping sweeper, scraping sweeper, and high-pressure water cleaning device were used to faster remove the stick mark on the conveyor belt. We have achieved one provincial level construction method, 6 innovation patents, 4 new patents, and one science and technology progress award by Chinese Transportation Authority. The third part is the field application of this equipment. Application scenario. This equipment is suitable for marking transportation in inclined shaft and vertical shaft of underground engineering by drilling and blaster method or TBM method. A total of 164 applications have been promoted, with sales reaching 70 million euros. This equipment has been successfully used in Tel Aviv Red Line in Israel, Beijing Subway, River Delta Water Resource Location Project. The project in Israel was constructed by using EPP TBM. The marking lift height is 31.5 meters. This equipment shortens the construction period by an average of 52 days per kilometer and reduced the marking cost by 400,000 euros. The Pearl River Delta project was also constructed by EPP TBM. The lifting height of the mark was 51.53 meters on average. The construction period was shortened by 75 days per kilometer, and the marking cost was reduced by 270,000 euros per kilometer. The fourth part is the social benefit of this equipment. This equipment meets the requirement of sustainable development and is green and environmental friendly. The closed-type marking drive by electrical power is low energy consumption and low noise generation. It can be continuously operated. This equipment has served a total of 25.3 kilometers of railway tunnel construction, 33.6 kilometers of subway construction, 15.7 kilometers of water tunnel construction, and 1,400 square meters of underground parking lot construction. This equipment can reduce the risk of personnel working under height. The closed-type marking system avoids leaking risk and soil falling from height. The information management realizes real-time monitoring of equipment operation state. The protection measure can automatically shut down the machine in case of emergency. The machine can be served for a long time with a stable operation and a low malfunction rate. The next few pages is showing the application of this machine. Application of Guangzhou Foshan Intercity. Application of Beijing Subway. Application of high altitude railway tunnel. Application of mountain railway tunnel. Application of the Pearl River Delta Water Resource Allocation Project. This page is showing the inspection report issued by the Chinese authorities, as well as the recommendation letter from the clients. Thanks for watching.
The video, that's very impressive. The video was a little bit too fast. I hope it's okay for the audience to understand, especially for the afternoon session. Yeah, usually it's not easy, but yeah, thank you. And yeah, so there's a difference about the deep underground TBM spoil transportation. Usually it's typical for the shaft, deep shaft. So also very impressive. And then next one will be geometry control system. Also different technology. Let's go through that one. Okay. Okay.
The Sagun project, also known as Geometric Control System of the Shotcrete robot, forms part of Dragado's strategic line in the use of advanced technologies and automation to improve processes, increase performance and reduce costs.
The Sagun device has been developed by Dragado's Research, Development and Innovation Department, led by Dr. Miguel Segarra, which is part of the Systems and Projects Control Directorate.
It has also benefited from the input of personnel from various Dragado's departments, including Germán Moro, Head of Topography Service, and Alejandro Sanz, Head of Underground Works Service. Both services belong to Dragado's company's headquarters in Madrid, Spain. Furthermore, the Sagun project has benefited from the input of Dragado's Canada personnel involved in tunneling initiatives, notably Jacobo Trigo, Director of the Construction and Surveying Technical Support Department in the REM project, Réseau Express Metropolitan, in Montreal. This was the setting for the inaugural Sagun production trials, and the device has played a pivotal role in the shotcreting phases of the tunnel construction. Dragados entered into a research contract with the Cardiff Technology Centre in Valladolid, Spain, which was fully funded by Dragados. The contract was for technology development and assembly of the device. Cardiff has been a long-term collaborator of Dragados in research and technology projects for more than 20 years. Sagun introduces a novel approach to the particular problem of providing the shotcrete robot operator with the best possible information about the shotcrete needed in the tunnel, thus introducing many improvements in the execution cycle. There are some solutions on the market that are able to assess the existing shotcrete thickness and compare it to the theoretical design. However, the results of this calculation can only be displayed on a computer screen. This is an exceedingly difficult problem to solve because there is no systematic way to map the shotcrete thickness information seen on the computer screen onto the tunnel surface. Shotcrete robot operators can only look at the screen and imagine where the shotcrete thickness needs to be added or removed on the real tunnel surface. This is an approximate process, prone to error and subject to the judgment of the shotcrete robot operator. Prior to Sagun, shotcrete robot operators and surveyors struggled to accurately place shotcrete and measure its thickness, relying on manual processes that were time-consuming and resource-intensive. Sagun represents a novel and unique approach and a huge improvement over existing solutions. Sagun can project the required shotcrete thickness at any point on the tunnel surface directly onto the tunnel surface. The shotcrete robot operator only needs to look at the tunnel to understand the task to be performed, which is displayed with unprecedented accuracy in user-defined areas showing different colors and numerical information about the difference in centimeters between the actual tunnel surface and the theoretical one. This previously unattainable feat relies on the detailed point cloud acquisition by the integrated LiDAR unit, the generation of thickness maps and the calculation of deformed thickness images to be projected onto the screen, formed by the irregular tunnel surface previously scanned by the LiDAR. Sagun brings several advantages and benefits to the shotcrete process in tunnels. The execution cycle is shortened, making the design and planning of the job easier. Safety is improved as workers are no longer exposed to dangerous tunnel areas. In addition, the quality of the finish is improved, avoiding later reworking and improving project planning. Finally, shotcrete robot operators gain a better understanding of the job to be done, and the amount of shotcrete required, allowing them to complete the job in a more sustainable way. The satisfaction of the construction team and the client is increased due to efficient operations. Furthermore, the Sagun device has the potential to improve the execution cycle even further, and new, more advanced versions of the device are being researched, with features to be integrated such as determining the shotcrete resistance of placed layers, allowing the next layer to be placed earlier, thus gaining more time in the execution cycle. Sagun is a project exclusively by Dragados whose financing has been carried out with its own funds. Segun performance improvement of shotcreting operations depends on several parameters such as tunnel diameter. Performance metrics obtained at the REM project in Montreal throw the following results when compared the SOGUN-based shotcreting process to the conventional one. In section reprofiling and excavation by traditional methods, Segun can improve performance by 100% and execution time is reduced by 50%. In shotcrete operations, regularization, structural or fireproof layers, Segun improves performance by up to 200% and reduces execution time by 67%. Segun has been tested in Eglinton Crossdown Light Rail Train in Toronto and REM in Montreal.
I would like to introduce you the Segun. That is a revolutionary technology that was created by Dragados in Spain and we put into operational service here in Montreal. The Segun is a mobile system that takes only 30 seconds to take the geometry of the tunnel, process the data internally, and finally produce a visual map on the tunnel showing the difference between theoretical data and current situation. We use the Segun mainly for shotcrete application, but we can use the device also for excavation. In both cases, the site teams will be able to know what they need to build within high level of accuracy. The Segun increase the productivity, increase the safety, and reduce the cost significantly. We eliminate the need of tunnel from work by achieving centimeter accuracy in shotcrete application. After 3,000 hours of use, I can confidently say that this is how the future will be shaped using this kind of technology.
Segun is currently being used in REM in Montreal, Subway Line 7 in Santiago de Chile, Chira Hydroelectric Power Plant project in the Canary Islands. Dragados would like to thank its staff for their unwavering commitment to research and innovation as well as the support our worldwide clients have provided in this regard. We are grateful for the trust you have placed in our technical capabilities and for helping us grow and evolve. We look forward to continuing to work with you and to delivering the exceptional infrastructure projects and services you expect. Segun, an innovative, performing, safe, economic, efficient, and sustainable system for shotcrete geometric control.
Very impressive. So the next one will be by PPT. So, okay.
I'm very happy to give this presentation about our YouTube Smart Turning Radius Hardrock TBM. I love this TBM so much, so I decided to tell everybody by myself. First, I'd like to introduce our research and design team. This is our chef engineer. Mr. Jia Lianghui is the chef engineer of CIEG and expert of China Municipal Engineering Association and Beijing Shield Engineering Association. Here's our engineers. They are young and energetic. Then I'd like to give more information about the PSP station. Pumped storage power station serves as a green power source in China, and more than 100 PSP stations are being constructed in China. A single PSP station has diverse, complex, and three-dimensional multiple layered tunnels, which are constructed by drill and blast method all the time. The TBM method has not been popularized in PSP stations because there are two major challenges. The first one is that there are multiple small radius in drainage galleries, access tunnels, and other tunnels. The curve radius is about 10 times the tunnel diameter. The second one is that the single tunnel is about 2 to 4 kilometers long, and they are turned around and disassembled many times at the assembly site. And this is how we designed the TBM. The curve radius of the conventional gripper TBM is about 500 meters and about 300 to 500 meters for the shielded TBM, which are at least about 40 times the diameter of the excavation diameter, which cannot adapt to the tunneling with small curve radius. The new type of gripper TBM for the project adopts the structure of the shielded TBM and the bolt short support system of the gripper TBM, which achieved the curve radius of less than 10 times of the tunnel diameter. For example, the 3.5 diameter TBM has achieved the turning with the curve radius of 30 meters. The new type of gripper TBM adopts the spherical articulation system and the V-shaped layout thruster cylinders, which avoid the use of the torque beams to improve the turning ability. And a floating belt conveyor that could be adjusted in up and down, left and right directions is developed, which can adopt the curve radius of 30 meters. The new type of gripper TBM is designed to facilitate the remobilization. The total length is reduced from 260 meters to only 37 meters, and total weight is reduced from 550 tons to only 250 tons, which is lightened by 60%. It adopts the modular technology and is divided into cut-head, shield structure, and the backup system modules, and each module can be disassembled, transported, and assembled as a whole. The assembly period is shortened from 45 days to only 15 days, and the disassembly period is shortened from 30 days to 10 days. Subject to the length limitation, the TBM adopts the separation design of the human and the machine, namely, the control cabin is outside the tunnel, and we can realize the remote control and the smart tunneling of the TBM. We reduced the numbers inside the tunnel. And these are the applications and advantages. In the past 3 years, 16 sets of the new gripper TBM with a diameter of 3.5 meters have been made and applied for 27 PSP stations, which is almost 1/3 of the PSP stations in China. And this is the TBM finished the excavation of Jinyun PSP station, which is the tunnel length is approximately 4 kilometers. And it has went through 22 small radius of 30 meters, and that maximum advance rate has reached 660 meters per month, and the best daily performance is 38 meters. The hard rock TBM technology for the extreme tight curve has been gradually extended to other fields like coal mines, metal mines, and other fields, with the diameter ranging from 3.5 meters to 9.5 meters. The conventional TBM cannot construct the tunnel with small turning radius, and drill blast method is with low efficiency. Compared with the drill blast method, the construction efficiency of the new TBM has increased by 3 times, and the safety 4 times. The forming area is reduced by 80%, and the carbon emission turns 60%. And we get many reviews from the customers and to many benefits to the society. Compared with the conventional pattern that construction parties do a lot of projects at the same time. In this project, one professional service provider, CIEG, can deal with multiple projects which achieve the consecutive application of the TBM and is recognized and prized by the client. The application of the hard rock with extremely tight curves has been continuously reported by major media in China for more than 40 times and won more than 10 awards for various associations in China and generated a number of patents and papers. And we have brought a lot of green power to China. I hope in the future we can bring more green power to China and to the world and make the world better. Thank you.
Thank you very much, Mr. Han Po. And so, as you know, we have 4 exciting innovations, and they are all different. They are all different monitoring and mark transportation systems and geometry control systems and the special TBM for very sharp curves. So they are all different. I fully agree with moderators in the morning, no matter the result in the evening is, but I think they are all the winners. And I'm very excited with all these 4 finalists. Yeah, very impressive. So now we would like to go to a roundtable discussion. So I would like to start from Professor Huang Hongwei.
Yeah.
So Professor Huang, from the presentation video, we know your innovative system have focused on 3 challenges, including unstable data transmission, and now cooperative measurements, and slow responding early warnings. Yeah, so you're focused on these three challenges. So my question, I have two questions for you. Number one question, because you said your system is a hybrid one. So what do you mean by hybrid in this system? So could you explain a little bit more about this hybrid?
Okay. Well, thank you very much, Mr. Jenny, and also for your good words for our innovations. And notice that we give the name just the advanced hybrid wireless sensor network. Just the short word is HWSN. It's just resolved for the three that's main challenge. Just you also mentioned, also that mentioned in our earlier the presentations. The static mesh is just for the unstable data transmission and the no cooperated measurements. And the second mesh is the trig mesh. The trig mesh is just for the slowing responded that pre-warning. And in addition, the dynamic mesh protocol is just for especially designed for the high volume, high efficiency data transmissions. Okay, so this is just the hybrid. We are just combined. We give the name the hybrid, considering static, the trig mesh, and the dynamic. Okay, so this is just the whole the constitutions for our the HWSN, especially for the mesh protocols. Yeah.
Okay, thank you very much for your briefing. Actually, I know you are a lot of innovations for your systems, and I want to know which is the biggest, the significant aspects, compare with the current system. What's your significant?
Well, thank you for your questions. Yeah. Okay, technically speaking, that's the wireless sensor network that has the two main aspects. In terms of the mesh protocols, that is the just we have just the HWSN. That means that we self-invented the ultra low. That's the powered, the self-organized. That's the mesh protocols. But others, it's just of integrations from the existing, for example, just the Zigbee or just the LoRa, and etc. And another one that we just mentioned for our three, that's the hybrid as the mesh protocol is for our the large scales, the super lines, and confined environmentals, especially for our tunnel and underground engineering, where the multi-pass, that's the effect to the radio, the propagations plays a very very important domains. Okay, and this one is for I think for our mesh. Okay, and but others, okay, is for the open. For the open, I mean the generic WSN for the open field, line of sight, and star the topologies. Okay, network. And in terms of that's the interface in the sensing in the interface, and we own that's the full the sensor interfacing capabilities for almost the sensors in the world, but others can work only partially with some that's the types of the sensors. Paul, that's the not sure if I covered all the points. If you have to say some words.
Yeah, well, I think you covered most of it very well, Professor. Well, one thing I would add is that there's not only the great and talented minds from China, but also internationally. Like in the UK, we have a team which is helping with the R&D, and we've also managed to now have across the world over 300 customers which are using the system, not just that system, but other Wyzen system. And together with our international partners from industry, we're pushed every day, which is pushing yourselves and us in the UK to produce these new systems and to improve and enhance our current products. Thank you.
Thank you.
Okay, thank you very much. Actually, monitoring, safety monitoring is one of my favorite topics. Actually, I have more questions, but not now because we have a very tight schedule. And okay, so we move to Mr. Zhang Penghui. And so the conveyor or the transport of a spoil excavated by soft, TBM. I think this is very important because affecting the efficiency of TBM tunneling. So important topic, and especially for deep shaft is even more critical. So my question for you is, what do you mean by 0 and 90 degree? So can you explain a little more about this?
0 is actually the horizontal transportation. 90 degrees is vertical transportation. 0 to 90 degree means we also include some inclined shaft. Normally, if the angle of the inclination of the shaft is more than 15 degrees, the soil discharge will be very difficult. So this device, this equipment can be a solution of this special scenario. Thank you.
So that means it can be used from 0 degrees until 90 degrees. Yeah, so,
yes.
So horizontal and like this. So, okay. So, and you mentioned it's a deep underground space. So how deep this system can go?
Now, based on our past project, our maximum depths of the shaft use this machine is 70 meter. Actually, this the capacity of this equipment can up to 100 meter. The transportation capacity can be more than 1,000 tons per hour.
Okay, so now at this moment it's 70 meters.
Yes, okay.
Okay.
70 meters, yes.
Okay. Okay, thank you very much. And also another question about the most significant innovation of your system compared to the current equipment.
Firstly, I will say this equipment, the progress will be faster. By using this equipment, we can minimize the stoppage of the TBM. Based on our own project in Pearl River Water Resource Project, 20% to 30% of the product activities were increased by using this equipment. Second one, I will say this equipment will be more safe. We can minimize the risk of the heavy lifting, risk of the falling object from high. Also, minimize the risk of the heavy locomotive operation. Also, we have many protection facilities and some detector on the machine, so can reduce the whole safety risk of the project. Second, number 3, I will say just now I say some inclined tunnel. If the angle is more than 15 degrees, the soil discharge will be very difficult. This equipment can be the solution. Number 4, just now mentioned in the slide, we have the central control system. Also, we have the one-button system. This one can help to create a automatic operation system on the construction project. Number 5, I will say compared to the battery, the locomotive, we can minimize the power wastage of the battery. So this also can help to create a green and environment-friendly construction site. Thank you.
Okay, thank you very much. So 5 aspects, but in short, I think it's better and safer.
Yes,
right?
yes.
Okay, so let's move to you, Dr. Miguel. Okay, so for shotcrete process, it's very difficult to control the thickness. Sometimes thicker, sometimes thinner. It's very difficult to realize the theoretical profile. Very difficult at the job site. And so I think this system, SOGAN, right, provides a very innovative solutions. So my question to you is what and how much does this system change and improve the tunneling process? So,
okay, thank you for the question. Well, I think that let's say the eureka moment here is when you realize that just seeing the circuit thickness needed on the walls, on the surface of the tunnel, the sidewalls, the ground, that's really, it's a real game changer. Why? Well, if you are able to see that and know what's the job that you have to achieve, then, for instance, you can avoid formwork because you will have very precise geometric information about the circuit that you need to apply. You can avoid lattice girders or pins if they are not needed for structural reasons. They are used many times just as a geometric reference, as a template. You can also avoid that. Just think about the time needed to install, I don't know, the lattice girders, the cost of the material, etc. This is really having an impact on the execution cycle at the tunnel. But also think when the robot operator is just applying the circuit, he's seeing the job, that the amount of circuit that he needs to apply at every point of the tunnel, and that means he's achieving a very smooth surface, a quality surface on the first run, on the first pass, the first drift. And that also has an impact in the tasks of the schedule that come behind, because there is no later rework or the amount is minimized. There is no later grinding of this type of task. Also, workers are not exposed to risky areas of the tunnel because they don't need to get into those parts of the tunnel to install the pins or the lattice girders or whatever. So it has, this small concept, which is very hard to implement, has many, many benefits for the site.
Yes, one more question. Yeah, so this system is very impressive, but yeah, from the video, so you have different colors on the roof. So it's a real-time system. That means, you know, you spread the concrete and the color change immediately.
Yeah.
Yeah.
Yeah, it is. I will explain how it works. You need first to load the theoretical profile that you want to achieve, or the surface that you want to achieve in the tunnel. And then we have an interface which is specially designed for the tunnel operators. So basically they have 3 buttons. You just press one of the buttons and the system scans with the LiDAR, built-in LiDAR, the actual tunnel surface. And then it calculates and makes a comparison between the actual tunnel surface and the theoretical tunnel surface. This process takes 30 seconds, okay? You've seen that in the video because there was some images of text saying that it was progressing on the calculation. This is shown also on the surface of the tunnel. Once this is done, you get the projection of all the thickness information of the circuit needed at every point in the tunnel in different colors, and you also have the numbers, the figures in centimeters needed at every point of the tunnel. You can configure the colors, we call that ranges and everything. There are a lot of configuration features in the applications. So when you need to, let's say, update the information, you simply press the button again. And in 30 seconds, you got the information again. If you compare that to installing lattice girders, I mean, there is no you will use SOGAN always. This is what is happening on our job sites.
Okay, thank you. And so what have been the challenges? Because you want to, of course, there's a research, and then you need to bring this technology in place, applications. So what's the challenges?
Oh,
you have
overcome. You have a lot of challenges there.
A lot of challenges, yes, I can imagine.
I can
so
explain.
Can you introduce a little bit?
Yeah, I can explain it a little bit. Yeah. Once we understood the problem, the first thing we did was looking for the right components in order to build the system. So we looked for everything, 3D cameras, laser beamers, laser distance meters, everything. We even tried discotheque lasers just to show on the tunnel wall iso thickness curves, and that didn't work. Okay, so we went very early to tunnels just to adapt ourselves to the harsh conditions. We built prototypes. We even built a fake tunnel in our premises just for trying. Okay, and we iterated several prototypes, always in contact with the job sites. That's the first part. You need something which is useful for the job site. The second part is dealing with the workers at the job site, because you need to make them feel they are part of the project. They are used to business as usual. If the only tool you know is a hammer, everything looks like a nail, and they didn't have a hammer, they have Shogun. So we identified an innovation champion there in REM Montreal, Jacobo Trigo, you've seen him in the video. And he was able, with our support, to manage the team on site that was actually producing the work. We traveled there, we trained them, we handled every situation with the people at the team. As they identify the execution cycle is shortened, they were concerned that they will finish earlier. But we were able to explain that it was more safe for them, and also they need to keep their skills honed. And that's the way to get more works. That's it.
Yeah, it was not easy. You did overcome many challenges. Okay, so then we turn to Mr. Han Bo.
Hello.
So I think we understand that some China projects has, very curved, very small radio. That's not easy because usually for TBM, it's not possible to, to bore these sharp curves. Yeah, so not possible for TBMs. But from this innovation, I think it's very impressive. So I want to know, maybe you can brief highlight the most innovative aspects of this system compared to the existing technology. Yeah, especially how small radio, this new technology, new TBM can bore. So I think, okay, the first question for you.
Thank you for your question, madam. I think I can elaborate in the following aspect for the most innovative aspect. The first one that we redesigned the team to give the ability to pass the small curves compared to the conventional method in the PSP station construction for these small tunnels with sharp curves. But the conventional method is the drill and blast force. It generates a lot of the shock waves and with low efficiency. And if we're going to use the gripper TBMs, the gripper TBM cannot turn the sharp waves, the very sharp curves. Normally they can turn the radius, for example, the gripper TBM, they can pass a curve of 500 meters. And for the shoulder TBM, the curve radius is 300 to 500 meters. So it's normally the curve radius is 40 times or more the times of the tunnel diameter. So we give it the turning ability to pass the small curve. This is the innovative aspect. The second is we make it shorter and it's easy for assembly, transportation, and disassembly. This would make the tunneling work more safe with less people, and we can shorten the construction period of the PSP station. And then we build the PSP stations more and more use this kind of the TBM, and we can bring more green power for China and also for the world. Thank you.
Thank you. Actually, in the past, we had several projects with very sharp curves, very small radius. And we couldn't use TBM because it was not possible. So I'm happy that now with this new TBM, so we can make it. And okay, thank you. And another question for you, why this new type of TBM can realize turning in very small curves? Okay. Yeah, how you make it?
Okay, so we redesigned the TBM. First, we divided the shield into two parts and used the spherical articulations to connect these two parts. That means we would give the first part, the front part, more degree of freedom to pass through the tight curves. And then we use the V-shaped layout of the thruster cylinder, which would replace the torque beams in the shield TBMs, which would hinder the turning in the sharp curves. And thirdly, we would use the floating belt conveyor. The floating belt conveyor can adapt it to the curve radius of 30 meters. So with these designs, we can make the TBM with the ability to pass through the curves like 30 meters, which is roughly 10 times the curves we have in the PSP stations. Normally, the tunnel diameter is 3 to 4 meters. So that is how we built redesigned the TBM. Thank you.
Okay, thank you very much. Because we have a very tight schedule today, as you know, we will have an opera in the evening, so we don't want to have a short one. so we need to finish this one. And I think all 4 shortlist innovations are fantastic. And I sincerely hope the application of these 4 new technologies can make our tunneling industry safer, faster, more efficient, and more sustainable. And thank you very much. Good luck in the evening. So thank you. Thank you. We give them. Thank you.